Okay, sorry. So I'm back. Sorry, can you hear me? Hello?
I can hear you.
Okay, thank you. Sorry, as I want to generate the battery still went down. As I connect, it just completely ran down. I was just managing it. Okay. Let me just share what I was. Yeah. So I think I discussed the trend. So that one just measuring the trend. So another thing before we go to the next one is to look at, now that we have found a difference, where do the different lies? Now that we have found a difference, here also, it's dealing with 3 or more groups. In fact, this one is 4 groups. Since we have found a difference in the 4 groups now, where do the different lies? So the post-hoc test, you cannot be talking of contrast here because here you are not using the real value. So, but you can talk about a post-hoc test. The post-hoc test here is not as robust as with the other one for ANOVA. It's just a way, intelligent way of some people going about the problem. But it's a little bit tricky, but it's very, not as if it's difficult like that. There are 2 options. You can decide to go and now pair them. See, there are 4, like this one are 4 groups. And how many ways can you pair 4 groups? We have already discussed it 6 ways.
6 ways.
6 ways you can pair 4 groups. This group now, group 1 to 4. It can be 1 and 2, that's 1. 1 and 3, 1 and 4, that's 3. Then it can be 2 and 3, that's 4. 2 and 4, that's 5. Then 3 and 4, that is 6. So there are 6 ways you can pair them. So if you want to follow Bob Ferroni's suggestion, if you decide to now pair them like that and not do the 4, he said that you should divide your p-value by 6. But to me, that is rubbish. Yeah, see, that's rubbish. If you divide your p-value is 0.05, your level of significance by 6, that shows that the small amount you are going to get, until your p-value is as low as that or less than that, you cannot say it's significant. Then some people now say that, okay, you can select out those ones you think make sense and pair them, like this example now. Out of the 6 now, you may decide to say, group 1 soya meal per week compared to no soya meal. No, there is no soya meal. No, group 1. That is the first test you may say, you may compare no soya meal with soya meal. You can compare 2 soya meal with group 2 with that's group 3 with no soya meal. So you compare each of them with no soya meal. In that case, you have done 3 groups, 3 tests. So if you don't eat, you have to divide before you can set your level of significance, you have to divide 0.05 by 3. That's one way. Another way, which to me make more sense, which would
so one.
I told them.
Yeah, the question. So another way, which I think make more sense, is to one man describe a method taking the difference between the mean rank of the different groups and compare them to the value based on the value of Z corrected for number of comparisons being done and a constant based on total sample size in 2 groups being compared. Like, look at the formula. The arrow view and arrow v, you are, the rank, the mean rank. In the something you can calculate the mean rank, which even the computer gave us the mean rank. Let me show you the result. Look at the rank. Look at the mean rank. That is average rank for each group. We are not talking of the total rank now. Total rank is where you add all the ranks, but you calculate for this group now. Total rank divided by 20 because there are 20 in each group. That will be the mean rank, average rank. So you may like to see. You look at the difference between the average rank of the 2 groups you want to compare. Maybe we choose for no soya meal and 1 soya meal now. The mean rank is 4.63 4.63 minus 4.15. This one is 4.63. You can remove 4.915. You want to see that particular difference between the mean rank. Is this greater than or equal to this side of the formula, which is Z alpha divided by the K times K minus 1. K means number of group, like in our case now. It's 4. 4. When you do it, you can say n plus 1 all over 12. All this from just put in the total n, of course, 80 for this situation. And for each of the group, also is 2020. When you to apply, if this part, which is the difference between the mean rank, is greater than or equal to this side, you know, the Z alpha, you know, if you set your the level to be what do I call it, 5% is 0.05. You divide that 0.05 by the K minus K times K minus 1. K is 4. K minus 1, 3. 3 times 4, make it 12. Divide by 12. We now go and look at it in the statistical table, the Z, Z, and now multiply by this. If what you get there is greater, what the mean rank is still greater than this side of the equation, that shows that it's significant. If it is less than, that shows that it's not significant. To me, it's just one funny way of providing solution. That is, so you have to now do it for the different pairs. It's just going to see to really know which one is significant, which one, where the different lies. Can you see now it's a little bit cumbersome compared with the post-op for ANOVA. And it's because this is non-parametric. It doesn't deal with the value, it deals with rank. Any question on this before we proceed? I'm sure you have any question. So we have looked at Krukawali's and median test now. For if you look at it, it's for independent. Independent is you have 4 groups that are not, they are not repeated, but they are independent group. So and it's one factor, one way ANOVA. So that is what you are using. You either use the median test or Krukawali's test. That's just the logic behind it. If you want to go and run it, just know how to get to non-parametric legacy value K independent sample. You see the Krukawali's here, you see the median test here. Any question? You will see the post is not actually inside SPSS. It's something so you have to use.
That was what I wanted to ask. I wanted to ask that. Yes, I wanted to ask that how do we do the post hoc for the non-parametric because it's not there.
Yeah, but if you
I look at it, I look for it, I didn't see it.
Yeah, you know it's not there. And if you just look at the formula, you just apply the formula. If how they got the formula, I don't know. So that's something. Though me, I try to, but to me, but what would you say now? Because that is just one of the drawback of the non-parametric yet. So when you are finding different now, to know where the different lie, you have to do. Though it doesn't, because some of the things you are able to use, there are something you have summarized from SPSS. It's not as if it's very difficult like that. It's all your summary, like the mean rank now, SPSS will give you, and you know the number of groups. So it's not something that is difficult. Any other question? I think we understand.
Okay.
Go on, sir.
Not directly on this, but the previous one we have done. When using SPSS to code your data, is there any command that you can give that will rank the data for you, or you have to do it manually, 1-1?
No. Well, okay, look at the one we just run now. You know you that run. Did you see any rank there? There's no rank. The rank I put there.
But what I mean, when you are entering the data, assuming you are dealing with 400.
Okay, now, sir.
Your sample size is up to 400.
It's not to 400.
You have to do it 1-1. Assuming the sample, let's say you're dealing with 200.
Okay, go, sir. Okay, share your share that your data. You want to share with us. I want to do it. Share
I
it.
want to share it.
I'll just explain to you. So what concerns you about the it's part of the command. They have already put the math. Look at it now. What you just have is the score and the group. This soya meal is the group. If you go to view, go to view after edit. Click on this, sir. Uncheck that value label.
Is it value?
Yes, value label, uncheck it. Yes, can you see? Because the group, you have coded them 1, 2, 3, 4. No soya meal is the 1. 2 is 1 soya meal. 3 is 4 soya meal per week. 4 is 7 soya meal. That's the group you belong. And these are the spam count. Chicken up. Just go and
No, I'm talking of the ranking, the ranking.
What I'm telling you, don't need to rank with hand. That's what I'm saying. The explanation I gave there is when you are doing it with hand for you to understand the logic. The expressors will rank it.
Okay.
In the process, they have put the formula there. The people that they have no program, they are programming, so it will give it to you. That's why it give you the mean rank, give you everything. So the expressor is not that it will rank it separately for you. What do you need the rank for? The ranking we just
Okay.
if you are calculating, if you are doing it with hand, and it's just for you to understand the essence of calculating and for you also to understand the logic behind it.
Okay.
You get it now. So you don't have any problem with that. You don't have business with even ranking anything. Any other question? Hugo, no question, right? Anyway, they won't be question because she was here last this. Dr. Larry.
Yes, Dr. Dolapo, good evening.
Yes, sir. I wrote a question in the chat box. I wanted to that you explained something about linear. I didn't get it. Oh, good evening.
About what? About what?
About linear something.
Linear what? Okay. Trend. Okay, let me go back there. It's about this test, Jokrin. This test, Jokrin, Tapstra. This test is trying to look at is there any linear trend. You know, when you are having 3 groups.
Yes.
Or 4 groups.
Yes, sir.
You know, or 5 groups or whatever. You know that if they are for the exposure variable, sometimes it may be ordinal. Ordinal means that those what define them to 3 or 4 groups is in step ladder.
Yes, sir.
It's not nominal. Like for this example now, this example we are using is ordinal because when you look at group 1, no meal, group 2, 1 meal per week, group 3, 4 meal per week, and group 4, 7 meal per week. You can see the exposure, which is the soya meal they took. It's ordinal in the sense that you know that they are not at the same level. I don't know if you understand me now.
Yes.
Unlike when they just say they want to know the spam, if they say they want to know the spam count of different ethnic group, that one is different because that one is nominal. Yeah, the sample from different ethnic group want to know the spam count. That one is not ordinal, it's nominal. So you cannot talk about trend. You cannot say is it increasing across. It doesn't make sense. But if you have an exposure variable that is ordinal like this one, you will want to see, okay, does the spam count increases as you increase the number of meal or it decreases as you increase the number of soya meal? I don't know if you understand me now. So in order to get that linear trend, you want to see if their median value increases across or decreases across. Is there any relationships? So that's why you use that geographic to test. So
I see. Okay.
It's significant now.
Understand now.
For the fact that it's
So if the
significant,
linear value in group 2, sorry, in the second group, for example, that's the one with soya milk is higher than the one in no soya. Is that what you mean? Then if the one median in the higher soya milk group.
Exactly. You want to see It's like as the soya meal increases, the sperm count decreases. That's a linear now across. You want to see that as you for another topic, maybe that it increases the whichever either it decrease or decrease there. You just want to
the
see
other way, yes. Okay.
It depends on the trend. You want to see
what's the name of the you called it a name?
Is there now? Are you not seeing
okay, John Terpstra.
John Terpstra.
Okay. Yeah, I've seen it, sir.
So the option is there in SPSS. The option is there. So
yes, I saw it.
Yeah. You know, you begin to see sometimes there are a lot of statistics that some people do. Sometimes the mathematical basis of it, you may not know. You may not understand, but just for you to understand how you can use what it means, what does it do, and how you can use machine to do it. I will follow it now. Okay, I think we'll proceed. Dr. Larry, I said you were not around with us yesterday.
Yeah, I'm so sorry. I was trapped in
problem. I'm just.
But I would love to have the video because I didn't get it.
I don't know. People said they didn't see it. I sent the video to everybody. They didn't see.
I didn't get the video.
Maybe there's a problem. I will check my dissing.
Okay.
I sent the video to everybody. Okay, I sent the video. I don't know. Let me just fill the form. Maybe I will check now just to see what really happened. That even the day before yesterday, when I sent it, and you said they didn't receive. No. Why people didn't receive it? ANOVA. Okay, let me just check what's happening that people didn't receive it. Because it's supposed to connect it to the YouTube so that you can get it.
So when you send it, will we be able to download?
No, you cannot download it. It's very. That's why the issue of that's why I link everything with YouTube, because I've been having issue with uploading and downloading. Yes, I know they are very big. Video something is very big, huge. So most of the time I will use more than 4 hours trying to upload. Sometimes it will even drop, no upload. When if I'm able to upload some, when I send it, many people cannot download also. So that is why the advice is that, okay, let me put all the video that I now create a YouTube account, just put it there, which you can actually access and watch there. Let me see. I don't know why it's.
All right.
Yes. Let me just show. In fact, let me just share this thing with you so that for you to see that it's there. I don't know. Can you see now? Can you see this thing? YouTube? I'm sharing it with you. Can you see?
Yes.
So, like the one we did yesterday now is ANOVA batch B. Can you see? Can you see? ANOVA batch B1, B2. Day for yesterday is this one. I don't know. And the way I share it, the way you share it is this. Look at it. Day 1. Not to play it to this is covering more than. No, it's playing. I'm coming. That's why the problem I have with this now. Let me pause this too. I will try and redo it. I don't know because I I put your this in there. No, I was trying to show you how I share it, and maybe there must be a problem where I don't know why anybody didn't receive it. Okay, let me just make effort because just one minute. Hmm. That's not what is giving me. I think maybe just proceed. I will look at it later. It's not giving me. I just want to show you what I did. Is I think this is so as it's here now. Okay, I think we will solve it later because I wanted to show you because your email I put on the email I send the way I usually send it and you receive it. I will go and look at what happened. Don't let that one delay us today. Let's just proceed what we are doing. Okay, let's quickly. If we do have a question on what we have done, so let's go to the next one. Any question from any quarter? Let's go to the Framer ANOVA now. So we have done Kukawali's and median test, and for one way another ANOVA, an independent, 4 or 3 group. If you remember, we that came for comparison of 2 mean with t-test and non-parametric counterpart. We also use median to compare 2 mean, independent mean, as a non-parametric counterpart of student independent sample t-test. From here, I say median is used to compare, it's a non-parametric test to compare 2 or more independent groups. Can you see? So that same median also work for 2 samples. It works for 2, 3, 4, as many samples, that median. So it's a non-parametric counterpart for independent t-test and non-parametric counterpart for ANOVA. That's one thing with median test. But I told you also that the power is very low. If you look at it, there are some things, look at it, this one now, is significant with Kawali's, there is not significant with median test. So that the power is low, and the only advantage it has over that is because it's the only option for non-parametric option for sensor data, sensor in survival analysis. Okay, let's quickly look at Framer ANOVA. This is the non-parametric counterpart of one-way repeated measure ANOVA. One-way repeated measure. It is used for testing difference between conditions when there are more than 2 conditions, and the same pattern have been used in all conditions. Look at what we did yesterday. The last one we did on repeated measure, I was trying to talk about sphericity. It is based on rank data. We rank the data for each person and add all the rank for each condition. Now, we have an example here. 10 women who consider themselves to be in need of losing weight were put on a special diet for 2 months. The weight was measured in kilograms at the start of the diet and then after 1 month and 2 months. Can you see? These are 10 women, 1, 2 individual women, separate women, who you put them on that. At the beginning, you measure their weight. After 2 months, you measure their weight. After 3 months, you measure, and after 1 month, after 2 months. So you have 3 sets of weights measurement for the same group of people. So look at the way. Now, how do you go about it? What you do is to rank in between. That is, for each person, you rank the weight. What rank? You compare the 3 for each person. If you look at it now, the smallest is the start weight for this person, followed by the number, this one, and followed by this. So that's why it's ranked 1, 2, 3. Start is 1, 2, and it's like that for this one. But if you come to this one, number 4, the highest is at the beginning. I think this person that was losing weight. The highest at the beginning is number 3. The lowest is at small 2. And you see 1, 2, 3 backward. So you rank them like that. When you rank them, that is what you are not ranking them vertically, you are ranking them horizontally. That is in between the 3 for the same person. You rank the weight. When you rank the weight, you now, for the start, you had all the rank. For 1 month, you have all the rank. For the other one, you had all the rank. Can you see the rank now? So if you want to see that the weight differ, this is the statistic. Is one complex? Well, it's not complex. I don't know where they get their 12. 12 over nk, k plus 1. K is the number of group, number of measurement. We know that it's 3.
Yes.
It's 3. Because they take 3 measurements. So the group of data, number of group of data is 3. So K is 3. And sigma, the sum of the round square. No? You know the way this one works. Look at it. So all this one will be the bracket. The 12 all over nk k plus 1 sigma r square minus 2 nk plus 1. So R is sum of the round for each group, then total sample size n, k number of conditions. In this case now there are 3 conditions. Start 1 month, 2 months. The test statistic has a chi-square distribution with degree of freedom k minus 1. So the degree of freedom for this one will be 2 because there are 3 conditions. So in this case, it's 2. So if you substitute 12, there are 10 here, 3 into 3 plus 1, you got there are 3 conditions plus 1. This is the sum of the rank we have looked at here. We have calculated here for each group. You square it. So when you calculate everything, it's 0.2. It is chi-square with degree of freedom of 2. You know that it should not be significant because the critical value for degree of freedom of 2 is 5 point something. So when chi-square is 0.2, even if it is 1 degree of freedom, it will not be significant. So you can see that it can now be significant. So there is no significant change in their weight. That's what it means. So how do you run? Who will run it for us? That is the result. Okay, run it, sir.
Okay. Okay. What is the thing?
Wait, diet
Which
and weight.
which of
It's diet and weight.
okay. Diet and weight, okay.
Yes, yes.
It's opening now.
Okay.
It's a bit slow.
Okay, let me stop here. Let me stop it. Let me stop sharing so that.
It's still opening. Okay.
Yeah, so that I can easily share.
still opening. Very soon it will be done. It has opened now, so I want to share it. I want to share it now. Okay. So can you proceed?
Yes, you can see it.
Can you see it? I've shared it.
We can
Okay,
see
so
it.
I go to analyze.
We have seen it, yes.
So I go to analyze the non-parametric test. Then my hand is very unstable. Then in this case, you go to, I think it's K
Yes.
related samples.
Yes, yes.
Related samples. So I'm now transferring all of them to this
Move
test
for
variable.
yeah, transfer all of them.
Transfer all of them to test variables. Okay. So we are there now.
Yes, it's
So it has already highlighted Fredman.
yes, just click OK.
Oh, I should not use the example and all this one.
Just leave that one.
Okay.
Let me see
what
is under the statistics. Let's see the option under the statistics.
Under the statistics, you have descriptive and
Okay,
quartile.
well, you can put there so that I can give you the descriptive, the quartile. Click on the quartile.
Okay.
Because that's where it can help you summarize it. But most of the time, before you do your differential, you will have done your descriptive. So that's why I mean people. Okay.
So should I okay?
Continue, yes. Okay.
Okay. So I want to stop sharing and then
yes,
I'll bring it back. Okay, so the result is in front of us now.
Okay. Can we see?
Can you see it?
Yeah, you can see.
Yes, yes, sir, we can.
Okay.
You see all the descriptive now. It's dealing with the real data. Those descriptive just for you to know the mean standard deviation of each group, just to know. It's dealing with each group, each condition. But look at the, can you see, you remember what we got? Is it not 0.2? 0.200. Our answer was 0.2, and that is the chi-square, and the degree of freedom is 2. Look at the p-value, 0.505, 0.905. It's not significant. Okay, you can stop sharing, sir.
Okay.
So you can see from what we have just done, the non-parametric test. Look at the result, the same result we have there. The same thing also when you talk about post-op. Or do you have any question before we talk about this post-op? Any question concerning the one we have done about Freeman and ANOVA? Any question? Okay, let's continue. So, for you to carry out, if let's say, though this one is not significant, but if let's say it was significant, how do we know where? Is it between the first and the second? Or between the second and the third? Between the first and the third? Where does the different lie? We don't know. So that is what was up. So it's the same logic for the other one. You either do, if you try to do three tests like that to compare the 3 groups. So you have to divide your p-value by 3, your level of signal by 3. In that case, you are ready to reject now, put it as 0.0167 instead of 0.05. Now, that's one option. Another option is to do the same thing you did for the other one. Yeah, it's only that the formula is even simpler. It's a little bit different. So you look at the rank. If you look at it, you give us the mean rank. That is the mean rank for each. So if you look at the difference in the mean rank and you calculate if the difference in value of the difference in the mean rank is greater than or equal to this side of the equation, it means that it's statistically significant. So if you do that for the 3 here, you'll be able to know if you really know where the different lies, if there's any difference. Any question? Any question? Okay, it's so simple. It's so simple. Now, we have looked at the non-parametric counterpart in these 3 days now. We have looked at ANOVA, one-way ANOVA, factorial ANOVA, 2 ways, and we also look at the non-parametric counterpart where we look at Ruka-Wallis, median, and Friedman. I don't know if there's any question generally in any of this area so that we can quickly go over that if there's any concern.
Yeah,
Because,
Doctor.
yes,
Dr.
sir.
Dolapo, maybe it's
No,
because I'm not.
You
I
are
mean,
not
I missed out.
yesterday. Yes.
Yes, I missed out 1 or 2. But just looking at the literature, you come across some other terminology that are also related to ANOVA, ANCOVA, MANOVA. In what instances do you use that?
Okay. Yes. If you look at it, if you look at the package, my package, you see that MANOVA and COVA, they are under the premium, though ANOVA is under essential. Though factorial ANOVA is under the premium. You understand me now? Because it's a little.
Okay.
So that and COVA, I was saying it yesterday, you were not around. I said that it's a blend between ANOVA and regression. You know, in ANOVA, you have quantitative continuous variable, which is the outcome. But your exposure variable is their group variable, they are categorical variable. But you may not have one, maybe another one quantitative variable that is serving as a confounder. When you put it in, that's ANCOVA. So it's another logic. But funny enough or interesting enough, in the module, you see it there. If you are even accessed from the night, you see in the module of the ANCOVA is the same. The example I use is that of that libido. I also use for that ANCOVA. We now put another factor in, add another factor in. So you see, so it's like a blend between ANOVA and ANCOVA. ANOVA is multivariate analysis of variance. You know, all this regression, ANOVA, all of them. If you look at it, you are looking at many variables, many exposure variables, but you have only one outcome variable. Yes, I'm now. Multiple regression. You look at one exposure variable, you have many exposure variables, only one outcome variable. That's why it's called multivariable analysis. Regression, multiple regression is not multivariate analysis. And that's where many people, they mix it up. Multiple regression is not multivariate analysis. It's multivariable analysis. The multivariate analysis, you have many outcomes, many exposure at the same time. So even as an example, if you check the model for MANOVA also, there is the only things that maybe what I need to put in the net also is the data file for each of them. To put it there if you want to run it, because in the model also I even put a screenshot. It's only that you just need for you to understand MANOVA, you need some just little knowledge of matrix. You know matrix in mathematics. If you see the model, you see some matrix there. So for example now, you know many times people want to know the determiner. You want to know the determiner. What determines systolic blood pressure? What is determining diastolic blood pressure? But systolic blood pressure and diastolic blood pressure, those are things that constitute blood pressure. Yes, I'm now. If you want to see, if you want to know the factor that determine systolic and diastolic at the same time in the same analysis, you can use MANOVA, multivariable analysis of variance, so that the outcome will be systolic and diastolic blood pressure. Then you can have many exposures But for the fact that your outcome measure is not only one variable, it's more than one, it's multivariate analysis. I don't know if you understand me, sir. Dr. Larry, you understand me?
Yes, yeah.
Yeah.
I got
Like now you can, if in fact, it's a very good example. Like that, if you understand ANOVA, most of the time when you want to look at factor, you are looking. That's why many people, when they are trying to study hypertension, they now change it to categorical. And though that's why many, clinicians naturally all over the world, they prefer using logistic regression because the outcome is categorical. They categorize. Somebody diabetes, instead of you to consider, you just have the cutoff 126. Okay, wait. Somebody gets blood sugar 125, and that person got blood 126. You say this 125 is diabetic. The other one is not diabetic. So you understand now. That's sharp boundary. So it make it easy to segregate people. So that's why they use logistic a lot. But sometimes you may want to, if you want to study blood pressure, what are the factors responsible? You want to use linear, you want to see retain, in a quantitative form. Instead of you to say cutoff, because those cutoffs are subjective. So if you do it, they just recommend the cutoff. That's what you are using. But if you just run it like that, instead of you to say you are running something for systolic blood pressure separately and say you are doing linear regression for systolic blood pressure, these are the factors that determine systolic blood pressure, and you have to run because the value of the systolic blood pressure differ also. You have to run separately. Though some people they try to reach a common and say mean arterial blood pressure, they try to say all over this or this, they combine systolic and diastolic. But if you want to use that systolic and diastolic way is measured, because what do you call it? I mean, arterial blood pressure is derived. It's not a natural thing. But the systolic blood pressure is there naturally. Diastolic is there naturally. So if you want to look at the factors that determine them, together like that, it's ANOVA you use because you are having more than one outcome at the same time. And you're going to have many factors that may be responsible. That is multivariate analysis of data. So it's we have factor analysis also. Multivariate analysis is a form of multivariate analysis. Factor analysis is a form of multivariate analysis. Multidimensional scaling. If you look at it there, we have factor analysis. Some of these things, I've learned something, you have to take it bit by bit because sometimes if you are too over-vicious and you are too high something, maybe will begin to roll away from you. They say, in fact, some people come in and they say that when are we going to start for them, that they have gone advanced, that have been left behind, that when are you starting again? They didn't start. And I said that what I do now is opportunity. Next week, we are supposed to go to linear regression. We'll quickly do 1 week. Can we do using SPSS? The following week, we'll do chi-square we have done before, just for 1 week, for people to catch up. Then the next one, we'll do t-test. We'll do it like that. When we mop it up before we now go to our regression, just for them. But I've recommended to those people that come in, I say, go and watch the video from the beginning. Those lecture video I put there from the beginning, from the basic. But when I started, all the lectures are there. So they are not those lectures, the workshop lecture, they are private. I mail it to you. But the lecture video, the workshop video, I mail it to participants. But the lecture video is in both of them are in the YouTube, or know that you can do it. They are unlisted. So anybody that is linked to my website can get it. That is a lecture. But the workshop video is only the people I mail it to, the people that attend this, that I mail it to, that can get access to it. I send the link through mail. If they cannot get it through the website, that's for the workshop because it's under private. Why this one, the lecture is under unlisted, which anybody that has link, once you have link to my website, you register there, you can have access to it. So I've already told them to catch up. So that is why I don't want to move too fast, because at the end of the day, you lose many people. It's only few of you that are interested in learning very well, that are consistent. Most of the people, they drop out. And at the end of the day also, if I need the critical number, I need some critical number. So all those things, we still do them. So as God permit, we do even meta-analysis. We run them. We need starter to run them. But survivor, we can run them with SPSS. Survivor. I've been running for people. Survivor analysis. The diagnosis, they have to do sensitive, so they have to set cut-off mark, so a cut-off point for tests. That's using ROC curve. All of them, they are there. Which some people are asking for it. Any other question? Any other question? Any other question?
Question.
Okay, maybe let's start reviewing what we have done. Let's start reviewing what we have done. Okay, someone, good evening, sir. How? Okay, no problem. Okay, he has left. Okay. Let me just open the what we have done. Is banner over. From the section, we try to look at our timetable. Well, I don't know, because I would like to be pragmatic so that we have room for improvement. So from what we have gone through, especially this was directed to Prof and Dr. Ikobo, because the other people, they have been around. No, they were around last week, so they just came back to reinforce. So I don't know. These are the things we plan to go through. Understanding the concept of family-wise error. That one is critical for understanding why you choose ANOVA instead of t-test for comparing more than two groups. Two means, the theory of ANOVA, the logic of X ratio, and F distribution. To me, the most important thing here is these two. The theory of ANOVA and the logic of F ratio are the most important thing. Then followed by this post-hoc, then followed by this plan contrast. Because post-hoc is preferred over plan contrast as far as I'm concerned. It's easier and more straightforward. So once you know the logic of this ANOVA and logic of X ratio, how to do post-hoc, if you don't even know how to do plan contrast, then the factorial ANOVA, when you have two factors, then these Kukawali and all, they are even simplest, because when you just go directly, you don't need to bother yourself, just go directly to, once you know that you cannot use parametric test, work for this one. So I don't know if there any area we are still having issue this area. Even this repeated measure is just sheer over ambition that make me to put it there. The repeated measure, because once you understand one way and then factorial, the repeated measure is a part of factorial ANOVA. But once you understand one way and logic behind factorial ANOVA and for independent factorial ANOVA, you're home and dry. So rather, it's step by step. When you get to understand those other one, you can run it now. Laterally, you get to do the other one also. I don't know if there's any area you feel that we have covered what we are supposed to cover all years, or any of these areas that you cannot confidently, because I believe anybody that attend this workshop should be able to analyze run analysis, not with arm, but with SPSS to run any of this and bring this result out. So I want to get the feedback from you.
I think it's okay, sir. We have achieved our objectives.
On my own side, there's no question.
Okay.
Yeah, it's all right.
Okay, we thank God. Yes, that's great. So
yes, thank you, sir.
Okay, thank you, sir. So what I just want you to help me do, for some of us that have been consistent, especially Dr. Balogun, Professor Tokidem, and Dr. Olagudwe. Olagudwe, well, she joined the first day, but the reason is our computer, our SPSS. She's someone that she want to participate, she want to run it. So say this is say we should wait. She will do another. It doesn't want to be. It doesn't want to be in a place, and it will not even run it the way where they are running it. So I will encourage you to be part of other training I want to do. I'm looking for a situation where you do the facilitation also. Like this, especially the one we are repeating now. Next weekend now, this coming weekend, we are going to do